Sorry I'm out today, guys. All I need you to do on a brand new sheet of paper, put your name and opener at the top, and then take 2 minutes, pick one of these equations to solve. Make sure that you show your work. Solve one equation in the next 2 minutes, go. So right now you should have a sheet of notebook paper out, your name and opener should be at the top, and you should be solving one of these three equations. Make sure you show all your work for full credit. Got about 1:15 left. Finish up in the next 30 seconds, please. Great. So let's take a minute. Let's go over these really quickly. I noticed in this first one that 9 is being added to x and -3 is being multiplied. Remember, we're going to do reverse PEMDAS. So we're going to subtract 9 on both sides of the equation first. Subtracting it on both sides keeps it balanced. So we're left with 3 equals -3x. If x is being multiplied by -3, I need to divide by doing the inverse. So divide by -3 on both sides, and x equals -1. So look at this second one. I noticed that there are 2 x's in this equation. 2x on the left side, 6x on the right. I'm going to move the smaller x so that I can keep it positive. It's a positive 2x, so I subtract 2x on both sides. That leaves me with 10 equals 6x minus 2x is 4x minus 6. Now, I need to get rid of subtracting 6, so I'm going to add it on both sides, keep that equation balanced, bring down 4x equals 16. Last but not least, I need to divide by 4, and I know that x equals 4. Now, this last problem is a little bit different because I have to do the distributive property. Those parentheses tell me that I need to multiply. 5 times x is just 5x. 5 times -8 is -40. A lot of you might have messed up your sign there. Pay close attention to your signs. Bring down the rest. All right, again, I noticed that I have x's on both sides. So I'm going to move the smaller of the two. It's a positive 5x. I'm going to subtract 5x on both sides. -40 equals, don't forget to bring down the sign in front of that constant 40. You have to keep the signs with it. 10x minus 5x is 5x plus 20. Now, I need to get rid of that addition of 20, so subtract it on both sides. If you borrow $40 from me and you borrow 20 more, you're in debt -$60 to me. That's still equal to 5x. We need to get rid of that multiplication, so we divide by 5 on both sides, which leaves us with 1x equals, how many times will 5 go into -60? Well, it's going to be a negative. I know that 5 will go into 50 10 times, but I need 2 more 5s with it, so it's going to be -12. All right, so the next thing that I need you to do is is we're going to unpack this standard. We're going to explain each step in solving equations as following from the equality of numbers. All right, asserted at the previous step, starting from the assumption that the original equation has a solution. We have to assume that all equations in Unit 2 have solutions, and we're going to construct arguments to justify our solution. So today we're going to prove that we can solve equations by justifying them. So, since we are starting a brand new unit, I want you on a sheet of notebook paper to write Table of Contents, Unit 2. Don't worry about this. You don't have to put that. So at the top, put Table of Contents, Unit 2. And then instead of putting the date, just put number 1. Let's call that our opener sheet. Number 2 is going to be our notes for today. I can justify solving equations. So right now you should be taking out a sheet of notebook paper, jotting down Table of Contents at the top, Unit 2, and making sure number 1 is opener, number 2 is I can justify solving equations. After you have your Table of Contents open and written down, I want you to put this in the second tab. We're starting Unit 2. Unit 1 was the first tab of your notebook. Put this in the second tab, and then put your opener right behind it. All right? Then take out a new sheet and label it I can justify solving equations. You can pause the video if the class needs more time now. All right, so here is our notes for today. If you would put a number 2 in the top right-hand corner of the paper, and if you would write the topic on the left side, I can justify solving equations. Then go ahead and jot down these 2 tables for me. We're going to work on justifying our steps. Again, feel free to pause if you need more time. Let's look at example 1. We have 5x minus 15 equals 40. Now, this is called a 2-column proof. There's statements on the left. There's reasons on the right, okay? So what we're going to do is we're going to solve this equation separately, but then fill in the rest of the statements and the reasons. We're going to solve it so that our work is not shown in our table, but each step is logical. So if we had 5x minus 15 equals 40, the first thing we would have to do is add 15 on both sides. That would leave us with 5x equals 55. Now, this is the next step. We don't need to show the work of adding 15 in our table, so we are going to write down 5x equals 55. What did we do to both sides of that equation? Well, we did the addition property. We added 15, addition property, and we did it to both sides, so it's the property of equality. The addition property of equality by adding 15 to both sides. Going back to solving this equation, we have 5 being multiplied, so we know we're going to have to divide by 5 on each side. Again, we're not going to show this work, but we're going to have left x equals 11. This is our next step that we put in our table, x equals 11. And what do we do to both sides to get to this step? We divided both sides equally by 5, so this is the division property of equality. And I've abbreviated, that is division and addition property of equality, but I'm making it shorter for your notes. So basically you're going to solve an equation off to the side, but you're not going to show the addition or the division on both sides. You're just going to make the statements. We went from here to here to here. We left out these little parts where we divided on both sides, where we added on both sides, and we don't show that work in our 2-column proof in our statements. We're just going to do that as scratch work on the side. But this is a statement and reason, a proof for us to prove that we know x equals 11. Let's look at example 2. Here we have x plus 4 over 2 equals 14. Now, x and 4 are both being divided by 2, but we don't know what x is, so we can't combine them and then divide by 2. So we need to undo that division by multiplying. Those would cancel out, so we're left with x plus 4 equals 28. This is our first statement here. So x plus 4 equals 28. What do we do to both sides to be able to get there? We use the multiplication property of equality. Oops, I'm going to abbreviate that. Now we have x plus 4 equals 28. We just need to subtract 4 on both sides. So we're left with x equals 24. That's our next statement. And what did we do from this step going to this step? Well, we subtracted by 4 on each side, so that's the subtraction property of equality. And we're done. We've justified it. Last but not least, we have example number 3. Now, I want you to try example number 3. A couple of you will go ahead and distribute. Some of you might subtract 10 first. Some of you might, add 10 first and then divide by 2. There are multiple ways to do example 3. So let's do it the way I think 90% of you are going to do it. You're going to want to distribute. So if we distribute, we would get 2 times p, which is 2p. And then 2 times positive 4, which is a positive 8, minus 10 equals 0. What property is that? Well, that's the distributive property. We're going to have to write that statement down. 2p plus 8 minus 10 equals 0. Now from here, we're going to combine like terms. 8 minus 10 gives us negative 2. And all that we did there was combine like terms. Last but not least, we're going to have to undo that subtraction of 2. So 2p minus 2 equals 0. We're going to have to add 2 to both sides. That means 2p equals 2. What property is that when we add on both sides? That is the addition property of equality. Good. Last but not least, p is being multiplied, so we have to divide on each side. So p equals 1. That is the division property of equality. So, in summary, all we're doing today is solving equations, again, like in Unit 1, but now we're putting them in 2-column proofs where we have statements, and we're going to write the reasons on the right side. So I'm going to give you time to practice right now. You have an algebraic proof puzzle. You're going to have, actually, let's give you 14 minutes on this. When you are done, after you've completed all 5 of them, then we're going to have you come to the board and work them, and then you can check your work. All right? You may go.